All right, we are back. So let's talk about completing the square, and let's start by graphing a function. And it's going to be a function that we know how to graph. Let's graph the function of y equals x minus 2 quantity squared plus 3. And we know exactly how this graph should look. It's graphing by transformations, right? This should look like the graph of y equals x squared, but you should go down 2 and right 2. Sorry, that 2 should be a 3. Down 3, right 2. So let's do that. You want to sketch the graph of that? Let's go down 1, 2, 3. Let's go right 2. That's where the tornado roundy point will be. And it'll look quadratic from there. Even though it's not part of the problem, let's get the right y-intercept anyway. This y-intercept is easy enough to check. 0 minus 2 is negative 2 squared is 4 minus 3 is 1. So I'll make sure to have the correct y-intercept. Neato. So here's the fact. It's easy to graph a function if it already looks like this. On the other hand, you can expand this out to get a new function. So let's do that. Let's expand that out. So that'll be x minus 2 times x minus 2, because that's what x minus 2 squared means, minus 3. And this, you expand that out by foiling. So foiling is just the acronym. Well, maybe let's not even foil. How do you multiply a thing times a difference? You can distribute. So I'm going to do something longer than one generally would, because I think it's useful to see why foiling works. Let's distribute this over that. You'll get x minus 2 times x, then multiply it by the negative 2 minus x minus 2 times 2. Cool. So what still needs to happen? Well, I guess we need to distribute again. Let's take that and distribute. Let's take this and distribute. Equals x times x is x squared. Negative 2x times x is minus 2. Distribute the 2 and the negative sign, I guess, in. 2 times x is 2x, and it's subtracted. 2 times 2 is 4. There's a negative sign there and a negative sign there, so it becomes positive. Oh, and I lost the 3. Right, there was a minus 3 next to all of those. All right, so finishing this up, 4 minus 3 is 1 equals x squared minus 4x plus 1. So I'm going to write this down. X minus 2 squared minus 3 is the same as x squared minus 4x plus 1. As a consequence, what does the graph of this function look like? It looks like the graph of that function because they're the same function. So here's the point of that slightly long exercise. If you could go the other way, if you could just know that that function, x squared minus 4x plus 1, is the same as this function, if you could just know that, then it would be easy to graph that quadratic function. So how do you figure out, without knowing in advance, that x squared minus 4x plus 1 simplifies to x minus 2 squared minus 3? That's what completing the square is. Completing the square is the act of taking an arbitrary quadratic function, ax squared plus bx plus c, and putting it in the form capital A, x plus capital B squared plus capital C. And maybe I'll make a little comment here. A, B, C, and A, B, C. These are constants. but not necessarily the same. So like the little b is not supposed to be the same as big B. They're just different constants. So why complete the square? It lets you do some things really easily. It lets you graph automatically. If you already had the function in the form that you get out of completing the square, this form, then you can graph. You know that you stretch vertically by a factor of a and flip if a is negative. Then you go left by b, or right if b is negative, and then up by c or down if c is negative. It lets you easily read off things which you would read off from the graph. Maybe you wanted to maximize or minimize. Once you see a graph, you know the minimum. You can just read it off, or the maximum. The quadratic formula is true, in fact, just because of completing the square. As an extra credit, you'll take the idea of completing the square and use it to explain why the quadratic formula walks. And let's see an example. Let's complete the square on this function. That should be a y. Equals negative x squared plus 6x minus 3. So here's one strategy. Let's just set these two things equal to each other and solve for a, b, and c. So I'll write down that equation. I'll pretend that a, b, and c are the unknowns. X is a variable, but I'm not going to treat it like an unknown. I'm going to solve for a, b, and c to determine them. So step one, I think I'll expand out the right-hand side. So let's start by foiling. And if you need the review of foiling, let's do that off to the side. X plus b squared, right? That'll be x plus b multiplied by x plus b. This is x squared. Right, so how do you FOIL? You take the first term, then you take the outside terms plus x times b, outside plus inside b times x, plus just the last terms. B times b is b squared. Equals x squared plus 2bx plus b squared. And that's definitely something off to the side, not something I would need to see right now. So let's use that and just FOIL out that. So that'll be a times x squared plus 2bx. bx plus bx is 2bx. Plus b squared, close parentheses, plus c. And allegedly that is equal to this. And let's just keep on simplifying to solve. So I guess the next thing I see is I can distribute the a. So doing that, ax squared plus 2abx plus ab squared plus c equals negative x squared plus 6x minus 3. And so notice, I want this side of the equation to be equal to that side of the equation. And here's the strategy I'll follow. For these two things to be equal, that means the x squared coefficients have to be the same, the linear coefficients have to be the same, and the constant terms have to be the same. So let's match those up. So the x squared terms need to be equal. The linear terms need to be equal. And blue. The constant terms need to be equal. So let's match those up. Let's see what those say. So the x squared terms need to be equal. That means a has to be, let's get the color code. Good. A has to be equal to -1. -1. The quadratic term has to be the same as the quadratic term on the other side. The linear terms have to be the same. 2ab has to be 6. And that was green. 2ab has to be equal to 6. And finally, ab squared plus c has to be equal to -3. And the job now is solve. And some of these are just already known. You already know that a equals -1. So let's take that -1 and plug that in there. That'll become 2 times -1 times b equals 6. So that's -2b equals 6. It sure looks like b is equal to -3. Very good. All right, so I know a and I know b. That means I know ab squared. So this last term, since I now know this piece, becomes a is -1 times b is -3 squared plus c equals -3. So writing that out, all right, -3 squared is 9, multiply it by -1, that becomes -9, plus c equals -3, add 9 to the other side, c equals 6. So now we know everything. -x squared plus 6x minus 3 is negative from the a term. X plus b, x plus -3, quantity squared, plus c plus 6. And before we use that, no, let's use it and then check. Let's use this to graph that thing. If I want to graph that as a transformed parabola, well, I know how to graph this as a transformed parabola. That negative sign means I should flip over the y-axis. So it'll be a downward opening parabola. I should go right 3 and up 6. So let's go right 3, up 6. I'll go ahead and make sure I have the right y-intercept. And you could find the y-intercept by using either side of this. Maybe I'll suggest it's easier to use that side to find the y-intercept. So plug in x equals 0. 0 squared is 0. 6 times 0 is 0. You're just left with a -3. So the y-intercept should be down at y equals -3. And I haven't checked the x-intercepts. I could, but I think this is a good enough graph. And let's even check some things. Let's check if the graph is reasonable by graphing both sides. Oh, here's an error. That should be a 3, shouldn't it? How to fix that error? Oh, well. I'll try to fix it before too many people get a hold of these notes. And -x minus 3 squared plus 6. Sorry, I was just writing things down so that I can now have Desmos graph them. So let's do that. -x squared plus 6x minus 3. Hopefully that more or less agrees with what we saw that the graph should be. Let's also graph negative parentheses x minus 3 close parentheses squared plus 6. Yeah, I'd say those line up pretty good. Groovy. I think I trust the answer. So there's one way of completing the square. You write down a system of equations and you solve for the unknowns. Here's another way. This way might feel more artistic. You perform algebra until you see a perfect square staring you in the face. So this strategy is going to use the fact that, as we saw, x plus b squared is equal to x squared plus 2bx plus b squared. So that means if you can ever see, looking at you, x squared plus 2bx plus b squared, then you can replace that with x plus b squared, and then ideally you'll be done. So here's the game. Try to arrange that all of the x's fit into a single piece that looks something like this. Nice. So let's try to do that. So one thing you notice about that is the coefficient in front of the x is just a 1. In the problem that we started with, the coefficient in front of the x was a -1. To get rid of the -1, let's multiply both sides by -1, or divide both sides by -1, right? It does the same thing. You'll wind up with a negative y equals x squared minus 6x plus 3. So far, so good? All right, so this plus 3 is like not really part of the analysis, so I'll just try to get rid of it. I'll move it to the other side and not think about it for a little bit. Negative y minus 3 equals x squared, and I'll even do a little bit more jiggery-pokery. I want the term next to the x to be of the form 2 times something. I want that to be plus 2 times something times x. Well, this is plus 2 times -3 times x. All right, so here's the target for what I'm going to have b. I'm going to have that try to be -3. But I can't just have that be -3, can I? I don't have a b squared. So I want a b squared to show up. So let's add the right thing to both sides to get that b squared to show up. And maybe instead, the better hint right here is -3 squared equals 9. So it looks like I need to add 9 to both sides of this. So adding 9 to both sides of this, I'll see negative y minus 3 plus 9 equals x squared plus 2 times -3 times x plus -3 squared. That's right. That's equal to 9. Those two things are equal to each other. And here's the whole point. This is now a perfect square. We have completed the square. We got a perfect square to show up. And that perfect square is x plus -3 squared. So that means, simplify this side a little bit, right? -3 plus 9 is plus 6. Negative y plus 6 equals, parentheses, x minus 3 squared. Let's get y on its own. Subtract 6 to the other side. Negative y equals x minus 3 squared minus 6. Let's multiply both sides by -1. Y equals negative x minus 3 squared plus 6. And let's just check that that agrees with what we just did. We started with the exact same function as the previous example, I think. Negative x squared plus 6x minus 3, scrolling out so that I can be sure of that. Yeah, negative x squared plus 6x plus 3 was this. And we did complete the square. We got negative x minus 3 squared plus 6. Got the same thing down there. I believe that checks out. So, excuse me, there are two strategies to complete the square. One, write down the equation that you would like to be true and solve for the unknowns capital A, capital B, and capital C. The other way is write down this equation, y equals the quadratic you'd like to walk with, do some things to both sides of it until you turn it into y equals something that looks like a perfect square plus a remainder. Groovy. So now's another one of the chances when I want you to do something. So you do, we'll come back, and then we'll talk through. Okay, you did it. Let's apply completing the square. Sorry, there were the two different strategies. I think I have enough space. Well, I definitely have enough space because I can do this. Let's insert a page after. That'll look like that. Cool. So let's apply completing the square to that function y equals 2x squared plus 6x minus 5. And I'll do it both ways. So one of them was saying, well, let's just let a times x plus b squared plus c be equal to 2x squared plus 6x minus 5. And I just need to match it up so that I FOIL out the left-hand side, match it up so that each of the coefficients will be the same. So FOIL out the left-hand side, a x squared plus 2bx plus b squared. Once you do it a few times, then you'll be able to do that step quicker. Equals plus c equals 2x squared plus 6x minus 5. Continue distributing. Ax squared plus 2abx plus ab squared plus c equals 2x squared plus 6x minus 5. And now set things equal to each other. So it looks like a has to be equal to 2. It looks like 2ab has to be equal to 6. It looks like pink. ab squared plus c has to be equal to negative 5. So let's go through those motions. Well, a equals 2. Great, done. Let's plug that in to the Pople equation. So 2 times a will become 4 times b equals 6. B equals 6 over 4, also known as 3 over 2. Nice. All right, so I know what A is, and I know what B is. Let's plug those in to try to figure out C. So let's take that bit and plug some things in. So A is 2 times 3 over 2 squared plus C equals negative 5. All right, so doing that, 2 times 9/4 plus C equals negative 5. We can cancel this 2 with one of the 2's in the 4. 9/2 plus C equals, and you know what? Let's get a common denominator in advance since I know I'm about to need it. Subtract the 9 over 2 to the other side. C equals negative 19 over 2. Let's write down our conclusion. So, oh, that used up more space than I wanted it to. So, 2x squared plus 6x minus 5 is equal to, A is 2, x plus b is 3/2, squared, plus c is negative 19 over 2. Nice. So there's one. Let's do this the other way also. So let's start with, I guess, strategy 2. Start with y equals 2x squared plus 6x minus 5, and try to apply this completing the square idea. So I guess the first thing to do would be divide both sides by 2 to get rid of this 2. So 1/2 y is equal to x squared plus 3x minus 5 over 2. And let's do a few things here. Let's move this to the other side. And let's take that 3 and write it as 2 times something. So 1/2 y minus, oh, no, it'll be plus 5/2. So there's the thing that got added to the other side, is equal to x squared. I leave that alone. plus 2 times 3/2 x. Oh, cool. That means that this term is what my b is going to be. And notice, oh, cool, that agrees with what we had earlier. All right, so I still want to see a plus b squared here. So let's just add a b squared to both sides. So 1/2 y plus 5/2 plus b squared. Let's see, b is 3/2. Square it, you get 9/4. So I want to add 9/4 to both sides because that's b squared is equal to x squared plus 2 times 3/2 times x plus 3/2 squared. And again, the thing to note is this is equal to that. I added the same thing to both sides. All right, so 1/2 y plus, let's combine these two terms together. 10/4 plus 9/4 equals x plus 3/2 quantity squared. So at this point, the square has been completed. All of this is 19/4, so let's subtract that to the other side. 1/2 y equals x plus 3/2 quantity squared minus 19/4. Multiply both sides by 2 to get rid of the 1/2. Y equals 2 times x plus 3/2 squared minus, got to multiply this piece by 2 also. 19/2 after you multiply that by 2. So there's the result of completing the square. And again, it agrees with what we got previously. Cool. So the two strategies do give consistent answers, which is good. They should. It's the same thing. And I guess all of that page worth of content was supposed to fit there. In conclusion, no, this is the wrong example again. In conclusion, 2x squared plus 6x minus 5 is equal to 2 times x plus 3/2 squared minus 19/2. All right, so one of the whole points of this is we can use this to graph this quadratic function, 2x squared plus 6x minus 5. And let's do that. Let's graph this thing. So it looks like Foster will all get stretched vertically by a factor of 2, but it'll still look like a degree 2 polynomial. It'll still look like a quadratic. We will then go left by 3/2, also known as 1.5. We will then go down by 19/2, also known as, gosh, that's negative 9.5. So point down here, negative 1.5, negative 9.5. Then it'll start opening upward. I guess we may as well have the correct y-intercept, which is easier to read right here. 0, comma, negative 9. And it'll keep on keeping on. Cool. That seemed pretty all right to everyone? Groovy. Oh, did I? Do. All right, this is deeply frustrating. Technology is not being my friend. So I'm going to break the video here, and I'm going to come back with just one small closing thing to say. All right, see you in a moment.